Good day, everyone. Today, I will be taking you through root finding using Raphson method of numerical solution. Here is a case study. Find the root of y equals square root of n, where n is a small positive number. Apply to n equals 18. Obtain the results correct to 2 decimal places using Raphson method. Solution. Given from the question, y equals square root of n, where n equals 18. The first thing to recall is the Raphson formula, which is giving us y of k plus 1 equals y of k minus f y of k over f prime y of k, where k start from 0, 1, 2, 3, and so on. That is, when k is 0, you insert the value of k in the Raphson formula to find your first iteration. When k is 1, you do the same to find your second iteration. When k is 2, the same to find your third iteration, and so on. From the question, y equals square root of n. Mathematically, you square both sides. Y square equals n. Y square minus n equals 0. Recall that n is 18. So when n is 18, I have y square minus 18 equals 0. So my f of y equals y square minus 18. From Raphson formula, we have f of y, and we also need f prime of y. If f of y equals y squared minus 18, f prime of y equals 2y minus 0, which is equal to 2y. Yes. While dealing with Raphson, we need an initial point, y naught, before we can start our iterations. But from this question, we don't have y naught. But you can get your y naught from your function. Remember, our function f of y equals y squared minus 18. To set your y naught, you ensure that the value of y in the function will be tending towards 0. Hence, it must not exceed 0. For instance, if you take y naught to be 1, and we insert 1 for y in the function, so I have 1 squared minus 18, which is minus 17. It is far from 0. If I try y naught to be equal to 2, 2 squared minus 18 minus 14, it's far from 0. If I try 3, 3 squared minus 18, 9 minus 18, which is equal to minus 9, it's far from 0. If I try 4, 4 squared minus 18, 16 minus 18 minus 2, that is close. Now, let's try 5. 5 squared minus 18, 25 minus 18. That is far above 0. So, the best y naught we can set here is 4. The reason for setting y naught to be 4 is to reduce the number of iterations. It means at y naught equals to 4, we are very close to the root of this function. Now let's start iterating. First iteration. When k equals 0. So y k plus 1, k is 0, y1 equals yk, k is 0, minus f yk over f prime of yk. If f of y equals y squared minus 18, definitely my f of y naught will be equals y naught squared minus 18. If my f prime of y equals 2y, f prime of y naught equals 2y naught. Now my y1 equals y naught 4 minus y naught squared minus 18 over 2y naught. y1 equals 4 minus, my y naught is 4. 4 squared minus 18 over 2 times 4. y1 equals, I can use calculator to express the values in the brackets. 4 squared minus 18. This gives 4 minus 0.25. y1 equals 4.25. Similarly, we continue the same process to find the second iteration. Second iteration. This is when k equals 1. So from the general formula of Raphson, y k plus 1, k is 1 here, 1 plus 1 is 2, equals y1 minus f y of k, k is 1, over f prime yk, k is 1. y2 equals, y1 is now 4.25 minus fy1. So my function will change from y0 to y1. I have y1 squared minus 18 over 2y1. So y2 equals 4.25 minus 4.25 squared minus 18 over 2 times 4.25. I can find the expression in the brackets. I have y2 to be equal to 4.25 minus 0.0073529. So my y2 equals 4.2426. 6. Another thing to take into consideration is when to stop the iteration. We stop the iteration when the value of our y converges. What do I mean by converges? When we start getting the same value of y, so we stop the iteration. Because as soon as you start getting the same value for y, no matter how much more you keep iterating, you will keep getting the same value. You can see that my y0, y1, y2, they are different values because I'm yet to get the same value of y. I will keep iterating. Third iteration. When k equals 2, y k plus 1, k is 2, y3 equals y2 minus y2 square minus 18 over 2y2. So y3 equals, my y2 is 4.2426 minus my y2 squared, 4.2426 all squared minus 18 over 2 times 4.2426. My calculator is here. 4.2426 squared minus 18 over 2 times 4.2426 gives 4.2426 minus 0.00004069. So I have y3 equals 4.2426. As you can see, the value of my y2 and y3 is the same. This means my solution converges at y3. So no matter how I keep on iterating, I will keep getting the same value. So I will stop my iteration here. Hence, the roots of y equals square root of n correct to 2 decimal places is 4.24. Peradventure, I set my y0 to be equals to 1. I will still get the same root, but I will have more numbers of iterations. The essence of setting y to be 4 is because at y equals 4, the function is tending towards 0, which is very, very close to the root. Thanks for watching. Don't forget to subscribe for more interesting and useful video.